Hey guys, today you are going to take notes for the topic of law of conservation of mass. We talked about this in class. You should have a fill in the blank note sheet. And even though I cannot be there, I am still going to provide you with this information. The PowerPoint does not have a lot of razzle dazzle, so bear with me. And just if you have questions, hold on to them until I return. So, what happens in a chemical reaction? This is all review. In a chemical reaction, the chemical bonds in our reactants are broken, the atoms are rearranged, and they form new substances called products. Remember, reactants react to produce products. The amount of matter does not change during a chemical reaction. The atoms are only rearranged to form new substances. And we show this in a balanced chemical equation. So this is what we've been talking about. You put everything together, toss in your formulas into a machine, whatever you want to do. They change all around, and you have new substances formed, but it's all out of the same atoms that you originally started with. Oh, if I go too fast, you can always just watch this later on my website too. So, chemical equations. Chemical equations are a way that scientists represent a chemical reaction that has occurred. It's like the recipe. It shows the rearrangement of the atoms in the chemical reaction. It is made up of chemical formulas that are involved in the reaction. The arrow, we talked about this as well, is used to distinguish between reactants and products. And we talked about how it is meant to say, or it means yields or makes or produces. It's not an equal sign because we're creating new products. It's an arrow to show that we are transitioning from our reactants into our products. Your reactants are the substances broken apart or combined. This is what you start with. They're on the left-hand side of the arrow in your chemical equation. Your products are new substances formed in a chemical reaction. This is what you end up with, and they're located on the right-hand side of the arrow in the chemical equation. So you can see the example down below here. Carbon plus O2, carbon plus O2 creates CO2. The equation says that carbon reacts with oxygen to yield or to make carbon dioxide. Your arrow shows the direction of the reaction. So your reactants will always be the beginning, and then you will end up with your products. A lot of this should really be review of the conversations and lessons we did throughout the week. All right, I'm going to move on now. So, what is the law of conservation? When substances react, many changes can take place. But in every case, the total amount of matter afterwards is going to equal the same amount that you started with. This particular law is discovered by Lavoisier. He's a French chemist. You don't really need to remember that name. It's just a bit of information. Law of conservation of mass. In a chemical reaction, Rxn is an abbreviation for reaction. The mass is neither created nor destroyed. So mass, and we're talking about the atoms. The mass of your reactants will always equal the mass of your products. If I start with 15 atoms in my reactants, I have to have 15 atoms in my products. All atoms present in the reactants are also present in the products. There must be the same number of atoms in the products and reactants. I know this sounds redundant, but the more times you hear it, in the many different ways we say it, hopefully it will stick in your brain. All right. Mass stays the same. This is also repetitive, but the mass of the products must be the same as the mass of the reactants. You are not going to magically gain or lose mass. Remember, the law states matter cannot be created or destroyed. So here's an example. You have 2 grams of sodium that reacts with 1 gram of chlorine to make NaCl. you know you must have 3 grams of sodium chloride in your products. It's simply doing math. You can also look at it as I have 1 atom of sodium, 1 atom of chlorine. So in my products, I should have 1 atom of sodium and 1 atom of chlorine. You must have the same number of atoms of each element on both sides of the equation. If you have 2 atoms of oxygen in the reactants, you must have 2 atoms of oxygen in the products. Again, I will say you do not magically gain or lose atoms. Okay? This isn't something that someone just decided to make up one day, say, hey, that sounds cool. Let's just try to get people to believe this. It is actually how chemical reactions happen in nature, and it is always going to apply. When you have a law, it is something that has been tested and proved, and it will not alter or change in any way. So here is where we get into some of that balancing equations thing that we talked about. So you have coefficients. This is the big number that's in front of the chemical formula that tells you how many molecules of that substance there are. So if I have 5 H2O, that means I have 5 molecules of water. And you can see the pictures there. That's 5 different molecules of water. It's still H2O. I just have 5 of them. The subscript tells you how many atoms of each element there are. Remember, you will never, ever, 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 never, 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 ever, never, 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 ever change a subscript, because that will change the chemical makeup of the formula and it will no longer be the same substance. The coefficient times the subscript tells you how many total atoms of that element are present. So 5H2O is going to be 10 atoms of hydrogen and 5 atoms of oxygen. If there is no coefficient, then there's only 1 molecule of that substance. Remember, you don't have to put a 1. The 1 is just implied. It's like when you're doing math and you have X and Y. You don't say 1X plus 1Y. You just say X plus Y. All right, moving forward. What does it mean to balance a chemical equation? Sometimes we have to balance an equation to make sure that we have the same number of atoms of each element on both sides of the equation. So to do this, we change the number of molecules by changing the coefficients. Never, ever, 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 never, 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 ever, never, 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 ever, ever will you change the subscripts. You change the coefficients until you have the same number of atoms of each element on both sides. This was like the practice that we did and the practice that you're going to do today. When we do this, we are saying how many molecules of each substance must be present before the reaction will take place. Remember, this is not something that scientists made up. This is how reactions happen in nature. It's like the recipe that I talked about. You have to have certain amounts of certain ingredients in order to yield or produce a certain amount of products. Same thing applies in chemistry. Alrighty. And how do I know if an equation is balanced? So you're going to check the number of atoms of each element on both sides, reactants and products. If the number of atoms of each element is the same on both sides, then the equation is balanced. So H2 plus O2 yields H2O. This is not balanced because in my products, I only have 1 atom of oxygen. Oh, why can't you see that? All right. The other one, you can see it in your notes. It says 2H2 plus O2 yields 2H2O. This is balanced. It's the same reaction. I'm still combining hydrogen and oxygen, but remember, those are diatomic elements, so they're going to be paired up. So 2 hydrogens, 2 oxygens. When they partner, they're going to create H2O, but if I only do 1 and 1, it's not going to create, it can't create 1 molecule of H2O. So I have to use 2 molecules of hydrogen plus 1 molecule of oxygen, and then that will be distributed between 2 water molecules. That is a balanced equation.